Hello all, welcome back to my channel. In this video we will discuss solid principles. Solid principle is a key concept in object-oriented programming language. Solid principle representing 5 rules that are single responsibility principle, open closed principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Let's see an example each one of them for better understanding. Let me create one console app. Let's open Visual Studio. Select create a new project, select a console app, just click on next. I'll give project name solid principle test, principles test app. Click on next, click on create. So this will create a one sample console project for you. So let me add one class. Right click on the project, add. You can choose a new item or you can select a class. Just click on new item, select the class, and here you have to give a class name. I'll give invoice. Just click on add. So invoice class added. Under this invoice class, let me add 3 methods: public, void, calculate total. And I will not write any implementation logic, just I will define a method definition. Next public, void, and print invoice, and this also method definition only. I will write one more method, public void save to database, save to database. And we'll discuss on the first one, single responsibility principle. The definition, it says a class should have only one reason to change. Each class should be responsible for a single part of a functionality. In the invoice class, have a 3 methods, is a 3 different functionalities. First one is a calculate total, second one is a printing a invoice, and third one is a data save to database. These all are 3 different functionality, but SRP says single part of functionality should have a class. So this is not a single responsibility principle. Now how we can apply SRP for these 3 functionalities? For that, let me add one more class. Here will be public class invoice calculate. Under this class, I am going to copy this calculate total method, and let me add one more class. Just I'll copy the let me write public class print invoice or invoice printing. Invoice print, and under this class I am going to write print invoice method, and I'll write one more class, public class invoice repository. Under this class, I'll write this save to database method. Now if you see here, each class should have only the single part of a functionality. The invoice calculate, only the functionality is a calculate total. Invoice printing have only printing a invoice method. Invoice repo have only save to database functionality. So this is a single responsibility principle. Next we will discuss on the second principle, open closed principle. Let me add one class. Right click on the project, add new item, select a class. I'm going to name it as open closed principle. open close principal. Just click on add. So now in this class I'm going to add one method which will apply discount for a amount. So let me add public double apply discount. Apply discount. So this will accept two parameters. One is amount and discount type. And amount comma, and here will be discount type. Discount type. Now based on the discount type I'm going to apply discount for a amount. So I will write a logic here. If discount type is equal to like a percentage, if it is a percentage, then I will return amount like 0.5 or 0.9 or something, and else if discount type is fixed, if discount type is fixed, then I will return amount, and here will be fixed, so I'll 50%, 50 fixed discount I'll give, otherwise I will return amount. Now if you see here, if you want to introduce one more discount type, we have to modify this base class, the OC principals class we have to modify. So without modifying this class we can't add one more percentage type. So this is a open close principle bad example, meaning a class should be open for extension but closed for modifications. You should be able to extend a class functionality without modifying this existing class and existing code. How we can do that? So for this same method we'll apply the open closed principle. So for that I am going to add in this same class I'm going to add, I'll declare one interface I discount. In this I discount I will going to write double apply discount, and this will accept amount. So I will not accept any discount type, just interface I define. In the interface I am written apply discount method. So now I will going to write one class with inherit of this interface. So let's say like a public class percentage discount. Let's say I'll take percentage discount. This going to inherit I discount interface. Here I am going to apply the logic for applying a discount for percentage, like this. Here I will return amount like 0.5 or 0.6 something. So in the above I have written 0.6, I will write a 0.6. Now I am going to write one more class with the fixed discount type. Let me add, I will copy the same, and here I will name it as a fixed discount. And the fixed discount, instead of here the percentage, I will minus 50. In the above example amount minus 50, so here also I will use a amount minus 50. So this is a percentage and fixed. Now I will apply one more I will add one more discount type, so which is not possible in this here without modifying the class, the base class. So let me add one more discount type. I'll just copy this, the same, and the third one I'm going to add a coupon discount. Coupon discount. So here if you can see, the coupon will be like 80% of coupon I got. So this is a, now the discount type we extended but implemented in a discount interface without modifying the base class. The base class I am not modifying, I am introducing one more class and I am implementing a same apply index method. So this is a open closure principle we can use. Next we will discuss on the third principle, that is a Liskov substitution principle. Let me add one class. Right click on the project, add new item. The project class name I will give bird. Click on add. In this bird class I am going to write a one virtual method. It's a fly. So let's say public virtual void fly. This method I will print the log like a flying. Now the bird class is added. Let me add one more class, public class sparrow. This will inherit a bird class, and I will not write any implementation here. So this is okay. So this is a bird class is internal, so I will make it as a public, and I will write one more one more class, public class penguin. This also will inherit from bird class, and here the implementation I'll override the fly class from the bird. So here let's say like throw exception or something, throw new exception of exception. I'll return the message as a penguin can't fly. Penguin cannot fly. Here in this scenario, if we see penguin, it can't fly, but it is inherited from a bird class. So the fly method should be implemented in the penguin class. So this is a causing issues. So now we'll apply open closure principle for this example. For that, we'll declare one more class, the same bird class with the abstract, public abstract class, let's say birds, because the bird class already defined, so I will define as a birds. So next I'll define one interface flyable, like that, public interface, because the flying should be, so I define as a flyable. So in this interface I will write one flying method. So now I am going to write a sparrow class with inherit of birds and flyable. So I will copy the same, and here will be okay, the same class name it will not allow, so just I will add a sparrows, and here will be birds and comma flyable. So now the bird class also it is inherited, and flyable interface also it is inherited. So when you are inheriting, the method should be implemented. So under this let's say public void fly, and here I'll write a console log flying. Now this is a sparrow class is sparrows. Next I will write a penguin class also should be inherited from birds. Public class penguin. I'll say penguin already defined, so I'll say penguins. Now it's a birds. I'll not inherit I flyable, so just birds. Now you can see the sparrows can be flying and implemented for I flyable interface. Here if you see the sparrows class, it is inherited from birds abstract class and also I flyable interface. The method fly method also it is implemented in the sparrows class subclass, and also the penguins class it is inherited from birds class. So the Liskov substitution principle says a subclass should be suitable for its a base class without altering a correctness. So this is a Liskov substitution principle. Next we'll discuss on the interface segregation principle. Let me add one more class. Right click, add new item, class. Here I'd say like human worker. Click on add. So let me declare one more interface here. Before that, public interface I worker. So in the I worker I am going to write two methods. One is a void work and void it. So this I worker class interface I am going to inherit in the human worker class. Inherit. So when you are inheriting, you have to implementation you have to provide. Let me provide. So now here I'll say like I'll print eating and the below one working. This will be working. And the similar way I'll write one more class robot worker. So just I'll say like public class robot worker. This also I will inherit from I worker interface, and here I am going to implement 8 and also work. So here if you see, the robot can't eat, the robot can only work. So here will be working, and here I am going to throw the exception. So like throw new exception method. So this is not a interface segregation principle. Now how we can apply for this same example for the interface segregation. So let me add here public interface I workable. Let's say I workable. So here I'm going to add void work, and I'm going to define one more interface which is a eatable. eatable. So in this eatable interface only 8. So now the human worker class can be inherited for these two interfaces. Let's say like I'll copy the same, and the human worker already class is defined, so I'll give as I workable comma I eatable. So now the both work and eat methods, it is implemented in the human worker in class. So the same thing I'll copy for robot worker also. But here the robot can only work, it can't eat. So I'll remove this, and now so robot worker also, it is the same class already available. So I'll say workers. So the robot workers only inherited I workable. So the method work class also it is implemented. So now it is a interface segregation principle is applied for this example. So next we'll discuss on the dependency inversion principle. Let me add one class for that. Add new. Let's say the class name is SQL database. Click on add. Now here I am going to write a one method to save a data into database. So let's say like public void save data, and this will accept one string data, or if you want you can define, otherwise leave. So just I'll add saving into database, SQL database. I'll say SQL database. Now I'm going to write one more class which is a SQL database services. Public class database services, and here I am going to write a object for this class. Let's say like private SQL database, like object I am creating, and SQL database. Now here I am going to use a save data method. So let's say public void save data and db dot save data. Here you can see the database services, it is directly depends on the SQL database class. It is if you want to switch a database, instead of SQL database you want to store in a Cosmos DB or MongoDB or MySQL. If you want to switch, so it is very hard to switch the database. Now it's directly it is depend on the SQL database class. So now how we can apply for the dependency inversion principle for this? For that I'm going to write a one interface. So just I'll take this. Let me add one interface, public interface I database, and in this interface I am going to write a save data method. So now I am going to write a one more one more class and method, public class SQL database. I'll inherit I database, and in this I am going to consume or implement a save data method, public void save data. Save data. This is a SQL database. SQL database. Okay, the same class is already defined, so I'll name it as a SQL databases. So now the SQL database class is inherited from iDatabase interface. Let me add, I want to switch to MySQL. So let me say MySQL database. So now this is a MySQL database. Is easy to switch the database. Now the MySQL database class is defined. It is inherited from iDatabase class. If you want to switch one more database like Cosmos database, you can switch. So this is how the dependency inversion principle it will works. So we already discussed the single responsibility principle, open closed principle, Liskov substitution principle, and interface segregation principle, and also dependency inversion principle. The first SRP, it says improve the maintainability by ensuring a single responsibility for a class. The open close principle says allowing a extending a behavior without modifying a existing class. And the Liskov substitution principle says ensure the subclasses can be used without unexception behaviors. And the interface segregation principle, it says prevents enforcing classes to implement unused methods. And the last one, the dependency inversion principle, it says promotes loosely coupled code using abstractions. If you like this video, please share and subscribe. Thank you for watching. Have a nice day.